Okay, hello. This is the first flipped classroom lesson that we'll be having. The purpose of these lessons basically is to go through some basic skills, some things you might already know outside of class, so we're not wasting time, so we have more time to work on the more difficult things as we go through the year. So this one in particular deals with the scientific method, theory, and variables. So the scientific method, depending on the different sources you look at, they go from 3 steps to 12 steps, whatever. I personally prefer about 5 steps. The first step then is to identify the problem. If there is not a problem, then there's no point in studying it. So you have to first look at what's going on and determine, is there a problem that I need to solve? Is there something I need to solve? Once you've done that, once you know there's a problem, you need to make observations of what's going on using your 5 senses. Taste, touch, smell, hear, that kind of thing. Now in chemistry, we're not going to taste things very often, so just keep that in mind. But anyway, so what you're going to do is, as you're looking at the experiment, as you're looking at whatever we're doing, you're going to observe, make observations of what you see happening, and try to start thinking about what's causing this. Once you have a little bit of that data, then you're ready to go ahead and, observation, that's what I said. Then you're ready to go ahead and create a hypothesis. All right? And a hypothesis is an educated guess to what's going on. If for some reason something keeps boiling over on us, we take a look at observations of what might be explaining that. Coming up with a hypothesis saying that a kid in China just dropped his paper is causing this doesn't make any sense. It has to have something to do with what we're seeing. So you create your hypothesis of what you think is causing it, and then from there I like to go to step 4, which is the explore stage. Now, depending on the sources you look at or you've been taught, a lot of times this step is expanded into many steps, but really in explore, basically you're going to do labs or experiments, you're going to do research on the computer, that kind of thing. You're going to take more observations and try and figure out, what you're doing. So after you've done your explore stage and you've gotten your data and you've kind of done your results, then you need to sit down and analyze it, and then you're ready finally to come up with your conclusion. Was your hypothesis right? Was that what was causing the issue? If not, then normally in a scientific or a research-based area, we're going to go back to step 3, which is hypothesis again, change something, and try it again. Now, in general chemistry in high school, we just simply don't have time to keep doing an experiment over and over and over until everybody gets it right. So our conclusion stage normally is going to be more of what happened, what your results were, and then in the end analyzing and deciding and discussing what went wrong. What did you do wrong? What could we have done differently? That kind of thing. So we will do more of an analysis of what we could have done better. So basically that's the 5 steps that we're going to kind of follow as we do things. Now, once you're done doing this kind of thing, then you're ready to move on to theories and models. A theory basically is a hypothesis that has been created that has been supported many times. So if we're doing an experiment and we think it's something new and it's working, then we send our procedure off to someone else in another school. They complete it and they get the same results and support what we think. Then we send it somewhere else and we send it somewhere else. Eventually, after enough people do that experiment with that hypothesis, it then becomes a theory. So for example, the theory of relativity. Other theories are evolution, as well as creation. Nobody has definitively said those are true or false, but there's a lot of support over many, many years that support those. Once there is enough, it's been around a long, long time and never been disproven by any way, it then becomes a law or a fact. So for example, gravity is basically, at this point, a law. as far as we know. Nothing has really done anything to change that opinion. Now, when you're younger, a lot of people will tell you that a law or fact can't be changed. I believe that it can. Someday we may learn there's a bunch of little itty-bitty people with bungee cords below our feet that are holding us down. Probably not, but you know, it could happen. But for the most part, a law is a fact. When Columbus theorized that the world was round, that was his theory. Once people started going around on ships and so on and so forth, and in particular, once we went out in space and were able to see that the world was indeed round, then it became a law. Now, when you're doing this, you have to explain it to somebody eventually. And this is where a model comes into play. It basically is a representation of your item or your ideas that you've come up with. Now, there are two types of models. The first one is a mental model. This is something in your head. So if you're talking about your new idea of how bonding happens, it's in your mind, you're talking about it. But that makes it kind of hard for people to understand. Even something as simple as directions. If you're trying to get somebody to go to a certain store downtown and you're telling them to go down I-35 and get off on Southwest Boulevard and then take a right on 16th Street, etc., etc., it's a little bit harder for somebody to find it. So usually we start with kind of a mental model, you know, in our mind, what's going on, but eventually what we need to do is come up with some sort of physical model. And a physical model is something you can see or touch. So for example, a model car, or in the case of directions, coming up with something as simple as a map would be very helpful. Now, in your experiment as well, you're going to have something called variables. And often in science then we also do graphing, which many of you have done a long time ago. An experimental variable basically is something that changes during the course of an experiment. Now, you want to keep your variables down to 1, maybe 2. If you have a lot of variables that change, it's going to be real hard to understand what's causing what change. So really, in a good experiment, you're going to have one variable that's changing so you can see what the results are due to it. There are two types of variables. The first type is called the independent variable. This is the aspect that you are changing. You're in control of it, you're making it change. So for example, if you were making Kool-Aid and you wanted to try and figure out what makes it taste the best, maybe how much sugar you put into the Kool-Aid is your independent variable. What happens due to the amount of sugar that you put in, or what the taste that results, is called your dependent variable. This is the result. So if you put in 4 cups and it tastes really good, then that's your results. So dependent is just based on whatever you change, this is what happens. Eventually though, because it's science class, we've got to show this. We have to have a physical model, so we'll do a graphing. When you graph an experiment, the independent variable values, be it how many cups of sugar, how many grams of something, how many milliliters of something, that goes on the x-axis. Okay, that's the bottom one. What happens, whatever data you get from what happens, is called the dependent, and that's going to go on your y-axis. So basically, that is our first lesson. And now what you need to do is, in the packet I've given you, is go to section K, and it says basic knowledge and vocabulary, and there's a short amount of questions for you to answer. And then have those ready for tomorrow, and we'll go over them real quick. Thank you.